Well, earlier we talked about derivative at a point or the instantaneous rate. Now, what happens if we want to look at derivative as a function? Derivative of a function, let f be a function. The derivative of a function is denoted by f prime. It's the function whose domain consists of the value of x, such that the following exists. F prime of x equal to the limit as h approaches 0, the f of x plus h minus f of x divided by h. Given a function f of x equal x to the third plus 2x, we want to find the derivative of f of x. Derivative of f of x is given by the limit at h approaches 0 of f of x plus h minus f of x divided by h. And we simplify this. We're missing a HQ term here. At h approaches 0, this becomes 0, this becomes 0. So then the derivative of f of x is equal to 3x squared plus 2. We want to find the tangent line to the curve at the given x equal 2. We then can calculate f prime of 2 to find the slope of the tangent line at x equal 2. F prime of 2 is equal to 3 times 2 squared plus 2. That makes 14. The slope of the tangent line here is 14, and we're given x equal 2. We can use this to calculate the value of y. Y equal 2 cubed plus 2 times 2. 2 cubes 8 plus 4, that's 12. Now that we have the value of x and y, we can find b. So 12 equals 14 times 2 plus b. B equals negative 16. So the tangent line to the curve at x equals 2 is 14x minus 16. Find the derivative of the function, then we evaluate the following. So let's go ahead and find the derivative of the function. F prime of x is equal to limit at h approaches 0, square root of x plus h plus 1 minus square root of x plus 1 divided by h. To simplify this, we multiply the numerator and the denominator with the conjugate of the numerator. The numerator becomes x plus h plus 1 minus x plus 1. Denominator 8 times square root of x plus a plus 1 plus square root of x plus 1. The numerator, after you simplify this, you get 1 divided by square root of x plus 8 plus 1 plus square root of x plus 1. So this equal to 1 over 2 square root of x plus 1. So this notation here is meant to evaluate a prime at 3. A prime at 3 is equal to 1 divided by 2 times square root of 4. That is 1/4. At 7, we then evaluate a prime of 7 is equal 1 divided by 2 square root of 8. That 1 times 2 times 2 root 2. That is 1 over 4 root 2. So why do we want the derivative as a function? Let's take a look at the relationship between f of x and f prime of x. Given f of x equals x to the third minus x, and let's go ahead and find f prime of x. And when you simplify this, you should get this is 3x squared minus 1. Okay. Now, let's take a look at the graph of f of x and f prime of x is already given. Okay. So let's first take a look at f of x. Well, f of x is increasing from negative infinity to negative 0.6, and we have a local max at x equal to negative 0.6. This corresponding to the slope, this corresponding to the graph of f prime of x. F prime of x is being positive here. F prime of x is above the x-axis. It's positive. Okay. That's corresponding to F prime of x is positive in the interval of negative infinity to negative 0.6. It's cross the x-axis at x equal negative 0.6. Okay. And then what happened to f of x? Well, f of x then decreasing in the interval of negative 0.6, and it's decreasing to 0.6. Okay. Since it decreasing, the portion of the graph of the derivative is negative, as you can see. So f prime of x is negative from negative 0.6 to 0.6. F of x have a local mean at x equals 0.6. So you can guess that f prime of x cross the x-axis at x equals 0.6. F of x then increasing from 0.6 to infinity. This then would tell you that f prime of x is positive from 0.6 to infinity. So we may be able to use the graph of f of x to predict what happened to the graph of f of x and vice versa. Okay. Let's go ahead and try to sketch the graph of f of x equal x squared minus 3 without calculating and graphing f prime of x. Explain on what interval is the graph of f prime of x is both the x-axis. So let's first start with the graph of f of x. F of x equal to x to the third minus 3. Excuse me, x to the second minus 3. So this is shift down 3 units. Compared to its parent graph, f of x equal x squared. And let's see if I can draw a nice curve. This is f of x. Okay, so I know that f of x is decreasing from the interval negative infinity to 0 and increasing from 0 to infinity. Without calculating f prime of x, explain on what interval is the graph of f prime of x is both the x-axis. So this meant when it increasing, so f prime of x is above the x-axis. When f of x is increasing, so it is on the interval 0 to infinity. When f of x fails to have the derivative at the point, f of x have no derivative at the point if it have a corner or discontinuity or a vertical tangent at a given point. Okay. Differentiable function. A function f of x is said to be differentiable at a if f prime of a exists. In more general, a function is said to be differentiable on an interval S if it's differentiable at every point in an open set S, and a differentiable function is one with f prime of x exist on its domain. Let f of x be a continuous. Let f of x be a function and a be in its domain. If f of x is differentiable at a, then f is continuous at a. If f of x is differentiable at a, then f is discontinuous at a. Here's the question for you. Would the statement be true? If f is continuous at a, then f of x is differentiable at a. Is this true? Well, the answer is no. For example, this function. This is the absolute value function. F of x equal absolute value of x. This function is continuous, but not differentiable at x equal to 0. Because right here we have a corner. So let's take a look at this Example. The graph of f of x is given. At what domain point does the function appear to be differentiable? Well, the function is differentiable when it have the derivative, right? So this function here, it cannot have the derivative at the vertical tangent line or the corner. So differentiable at the interval from negative infinity to negative 2 union with negative 2 to 4 union with 4 to infinity. Continuous but not differentiable. Well, at x equal negative 1, at x equal negative 1 and x equal 4, the function is continuous but not differentiable. At what interval does this neither continuous nor differentiable? We don't have one here because we don't have a discontinuous. So what it meant by saying the second derivative? The second derivative meant we take the derivative twice. So third derivative meant we take derivative 3 times. Okay. So second derivative, first we need to find the first derivative. F prime of x is equal to the limit at 8 approaches 0 of 2 times x plus 8 squared minus 3 times x plus 8 plus 1 minus 2x squared minus 3x plus 1 divide by 8. Multiply this out, simplify it, you should get 4x minus 3. F prime double prime of x is equal to the limit at 8 approaches 0 of f prime of x plus 8 minus f prime of x divided by 8. This is 4 times x plus 8 minus 3 minus 4x minus 3 divided by 8. This should equal 4.